Okay, welcome back class. So today we're going to learn on the second part of chapter 3, logical reasoning, which is arguments. Okay, for arguments, there are two types. One is general type, one is specific type. Okay, these two, what are the difference between them? I'm going to give you a very simple example. Okay, for a general arguments means generally all boys have short hair, right? This is a general statement here. How about specific? Then specific means you will label one of the boy. Okay, let's say here, Ali has short hair. This is very specific because it means Ali has short hair. It's not all the boys have short hair, but Ali has short hair. If you give them a name, it's specific. Okay, so the process of making a conclusion based on statements is called argumentations, right? Meaning that you are going to make conclusion based on a lot of statements. So for arguments, those statements we can name it as premise, premise, premise. Okay, so I wrote down three premise here because you have to remember the premise here means statements. Okay, so we look at this, we have to identify whether they are specific or general. Okay, for A, the triangle, the area of triangle ABC is at centimeter square. So is this general or specific? We have to see. Okay, they give a name for this triangle and it's very specific for this triangle ABC that the area is 8 centimeter. So this is a very specific statement. Okay, all prisms have uniform cross sections, which is true. And they say, oh, semua. This is a very general statement because they say every prism has uniform cross section. This is a very general one. Okay, so this is general. All multiples of 2 end with even numbers. Multiples of 2s, we have 2, 4, 6, 8, 10, and so on, right? And they are all even numbers. They ends with a even digit, and they say it's all semua. So it's a very general statement here because they say, oh, it's not giving you a specific one. 6 is a multiple of 2 and ends with even digit. No, it's all. Okay, 15 is divisible by 3, right? Correct, right? But is it specific or general? This statement here is only for the value 15. The digit is 15. So it's a very specific statement here. And 9 cubed equals to 729. This is also a very specific statement, right? It's not about x squared equals to something. No, they give you a very specific number here. It's a specific. Okay, the volume of a cube is x cubed, where x is the age of the cube, right? The volume of a cube, they didn't give you a specific value here. So they give you a general formula only. So this is a general. Okay, remember arguments, we have general and specific. Remember these two examples. Okay, so from general and between these two arguments, from general to specific, you can change from general to specific or from specific to general. There are two types, right? If it is from general to a specific argument, it is called deductive argument. If it's from specific to general, it is an inductive argument. So these two you have to remember. Let us look at example 16. Determine whether each argument below is a deductive or an inductive argument. Okay. All acute angles are less than 90 degrees. Oh. Then angle PQR is an acute angle. So angle PQR is less than 90 degrees. Okay, we look at these three sentences. The first sentence here, is it general or specific? Oh, isn't it? This is general. And until the last sentence, it becomes very specific about this angle PQR. Okay, from general to specific is a deductive argument. I use DA. But in exam, you cannot use DA. I don't understand DA. You have to write down the full sentence. Okay, next. All Sudoku competition representatives are members of the mathematics club. Jamal is a Sudoku competition representative. So, thus, Jamal is a member of the mathematics club. So, all, you see the keyword, all the members are members of mathematics club. Huh? This is very general. Then, until the last part, last sentence, thus, Jamal is a member of mathematics club. So, this is very specific about Jamal now. From general to specific is a deductive argument. Okay, huh? Okay, next one, the sum of exterior angle of a triangle is 360. The sum of exterior angle of a quadrilateral is 360. I give you two examples. Then the sum of exterior angle of a pentagon is 360. Pentagon, they give you three examples. Thus, the sum of exterior angles of each polygon is 360. So they are from very specific example, and they give you a general example. From specific to general. From specific to general, it is an inductive argument. I use IA, huh? But you write full name. Okay? Right. So now we proceed a valid deductive argument. So we are going to study more about deductive argument today. From general to specific, huh? Okay. A valid deductive argument can be categorized into three forms. There are three forms of DA. Okay, DA is deductive argument. Okay, we look at this form 1. Huh? Premise. Just now I told you premise means statement 1, statement 2, then you get a conclusion. O, A, R, B. Then you get a C is A, C is B. Form 2, if P then Q. So P is true for premise 2, conclusion, Q is true. Form 3, if P then Q, statement 1, not Q. Okay, remember these two. Opposite, huh? Not Q will come first. Okay, Q will come first, and you add a not in front. And not P is the conclusion. Okay, this word here, valid, is very important. To see whether it's a valid DA or not, you have to check. Huh? Okay, for example, I give you an example. OARB. Then for premise 2, you found out that it is C is B. If they say C is B, then C is A. Right? Is it a valid deductive argument? Is it valid? No, it is not valid. Because these two change position. No, you cannot change the position. Okay? Then if we see form 2, yeah? Okay, premise 1, if P then Q, when you see this, then premise 2, you will say Q is true. Premise 2, Q will be written first. Then only P will be the conclusion. If it's this way, meaning it is not valid because it didn't follow the form 1, form 2, form 3, not valid. Okay? Wrong. Right. So are the following arguments valid and sound? So for this topic here, you have to determine whether is it valid and is it sound. Huh? Okay, premise 1, let's look at this example. All actresses are good at dancing. Jasmine is an actress, premise 2. Conclusion, Jasmine is good at dancing. So from here, we can see that this is form 1 deductive argument because all actresses are good at dancing. OARB. Right? All actresses are good at dancing. So we look at premise 2. Jasmine is an actress. Jasmine is C. And C is A, yeah? Yeah, actress, correct. Then Jasmine is C. C is B. Jasmine is good at dancing. So does it follow the argument form 1, 2, 3? Yes, it follows form 1. So this is a valid deductive argument. Then we have to decide whether it's sound or not. Sound means that all the premise 1 and 2 and conclusion must be true. Then it will become sound. If one of it is wrong, is false, meaning it is not sound. Huh? So here, all actresses are good at dancing. Is this a true statement? No, it's not a true statement because not all actresses are good at dancing. Maybe some of it are good at acting, some are good in singing. So this is a false statement. Okay, so premise 1 is already wrong, meaning that this argument here, deductive argument here, is not sound. Okay, there are two things that you have to remember, yeah, valid and sound. Okay, so example 17 here. So they're asking you, are the following arguments valid and sound? If not, justify your answer. So I wrote down the hint here. You have to follow these three forms. So premise 1. Then 64 is a multiple of 16. 64 is an even number. So from looking at this, we know it's form 1, right? O, A, multiples of 16 is your A. Are even numbers is your B. So C, 64 is your C. C is a multiple of 16. C is an even number. Now that follow, isn't it? So this is a valid deductive argument. Then we have to check whether it is sound or not. All multiples of 16, for example, what? 16, 32, 48, they are all even numbers, which is true, right? Okay, then we have to check whether 64 is a multiple of 16. Is 64 a multiple of 16? Yes, because 16 times 4 is become equals to 64 here. So this is also a sound deductive argument, valid and sound. Okay, we go to D here, right? We have to analyze it, huh? If then, right? If this is your P, then this is your Q. If A is not equal to 0, then A x to the power of n plus b x plus 6 is a quadratic expression. Okay, if something, then something, right? If P and Q can be either one. So we have to check our premise too. A is not equal to 0. This is your P, right? So P is true. Conclusion is your Q. A x to the power of n plus b x plus c is a quadratic expression. Is it valid? Yes, it is valid because it is a argument form 2. It's a valid deductive argument. So to check whether it is sound, we have to check, huh? So if A is not equal to 0, meaning A can be 1, 2, 3, 4, and so on, then you change the A to a value, x to the power of something is a quadratic expression. Well, it is not true because to get a quadratic expression, remember chapter 1, to get a quadratic expression, you have to refer to your n value, not the A value. A value is only whether you get a happy face or a sad face, but n decide whether it's quadratic or not. N must be 2. So the statement must be if n equals to 2, then axn power of n plus bx plus c is a quadratic expression. Then it will be true. So for this case, it is false. Ini salah. Okay. Then they also give you the conclusion axn plus bx plus c is a quadratic expression. This one you cannot say is true because n, they didn't give you the value of n. So this is not sound. It is valid but not sound. Okay, valid means it follows this form. Not sound means one of it is not true. If k is divisible by 8, then k is divisible by 4. Okay, if k is divisible by 8, this is your p, then k is divisible by 4. Here, q. Here. Then we see 12 is not divisible by 8. 12 is not divisible by 4. They add a not here, isn't it? So it must actually follow form 3. But did it follow? No, isn't it? Not Q is true, meaning that for premise 2, you must write about not Q. Right? Meaning for premise 2, it must be 12 is not divisible by 4. They did not follow this form 3. So this is not valid. Or we say is invalid deductive argument. Okay? Then we have to check whether it's true. Okay. If k is divisible by 8, then k is divisible by 4. 12 is not divisible by 8. This is true. 12 is not divisible by 4. 12 can be divided by 4, isn't it? Because 12 divided by 4, you get 3. So by looking at this conclusion, we know this is wrong. It's not valid and it is not sound. Or we can use the word unsound. Right. Last one, premise 1. If k is an even number, then k plus 1 is an odd number. If k is an even number, then k plus 1 become odd number. Yeah, like for example, k if it's a 2, 4, 6, 8, 10. All these value you plus 1, it will become an odd number. Premise 2, 8 plus 1 is an odd number. Conclusion, 8 is an even number. That it follows these 3 forms here. It can be either 1 or 2, isn't it? If it's a 1, P is true, meaning you have to write down statement P first. Meaning it has to write down 8 is an even number first. Only then your conclusion will become 8 plus 1 is an odd number. So this is not valid, invalid, because it does not comply with this either one form. Or we say it's an invalid deductive argument. But we have to see whether these are true or not. Yeah, we know that premise 1 is already true. Then premise 2, 8 plus 1 is an odd number. It becomes 9, right? 9 is an odd number, true. 8 is an even number, true. So it can be not valid, but sound. Okay? So example 18 here, form a valid deductive argument for each of the following situation. So they have 3 segments for you. You have to form either one. You have to form a valid. All mammals are warm-blooded. Okay, which is the form 1. All mammals are warm-blooded will be your premise 1. Cats are mammals. Cats are warm-blooded. Which one will come first? C is A. Mammals is your A. Warm-blooded is your B. C is A. Means cats are mammal will come as premise 2. Then conclusion, cats are warm-blooded. Here. Then we go to B. If x is greater than 0, then x has a positive value. If P, then Q, right? Okay. 6 is greater than 0. This is your P. P is true. Just that they change the x to a specific value here, 6. Then 6 has positive value. So this is argument form 2. So premise 1, premise 2, and conclusion. Then the last part, if x is an odd number, this is your P, then x plus 1 is divisible by 2. This is your Q. 18 plus 1 is not divisible by 2. 18 is not an odd number. They add a negation, which is form 3. So when it's a form 3, means your Q will have to come first as your premise 2, not Q. Which one is not Q? Yeah, this is not Q. Because this is your Q, so this is not Q. Okay. So if premise 1, you copy down, then premise 2, this will come first, not Q. Then only the conclusion is not P. Okay. Look at example 19. Write a conclusion for each of the following deductive argument to form a valid and sound deductive argument. Valid and sound. All whole numbers are real numbers. So from here we know it's premise form 1. O, A, R, B. So they gave you a specific one. 38 is a whole number. What's your conclusion? 38 is a real number. B. If P, then B squared minus 4AC more than 0. Then we look at premise 2 is 2x squared. See, they put the A as 2 now, your B as P, and C as negative 2 equals to 0 has real roots, meaning P is true. What's your conclusion? You have to write down the Q, but you have to change the value of ABC because it becomes a specific conclusion. Your A will become 2, This will become 2. From here, you have to refer. And your B will become P. And your C will become negative 2. So when we write down, it becomes B squared minus 4. Your A is 2. And your C is negative 2. More than or equals to 0. Okay. Thus, C. If a straight line y equals to mx plus c is parallel to the x-axis, then m equals to 0. So from here, we know premise 2, they say is a negation, not Q. So this is argument form 3. So what is the last part? You have to write not P. The straight line y equals to mx plus c is not parallel to the x-axis. Okay, example 20 now. If they ask you to write the conclusion, it is easier. But if they ask you to go back to premise 2 or premise 1, premise 2 will be much easier than premise 1. Okay, we will come back to A later. We do B first because premise 2 will be easier. So they say if the annual sales of A and C company exceeds 3 million, this is your P, then the employee get a bonus of 3 months salary. P then Q, right? So the conclusion is the annual sale of A and C company do not exceed 3 million. This is not Q. Not Q is at the conclusion. Meaning this is argument form 3, by looking at this table. So how do you write premise 2? Not Q, not Q lah. The employees do not get a bonus of 3 months salary. Do not. Okay. Then we go to C. Okay, if x equals to k, then k is a root of the quadratic equation. Or not quadratic, is an equation of this. Conclusion, x is not equals to 9. This is from where? From P or Q? It's from your P, right? So it's a not P, right? Because they say not equal to 9 and it's specific. They give you the K as 9 is specific now. So how do you write your premise 2? 9 is not a root of the equation. 3x squared minus 5 equals to 12. Right? You add a not here. This is also argument form 3. So now we go back to premise A, right? How do you form premise 1? Okay, premise 2, they say 36 is a prime number. 36 has only 2 factors. Sorry, it's 37, not 36. 37. Okay, from here, can we get it in the form 1? Okay, this can be your C. C is A. This can be your C. C is B. Right? So how do you write your premise 1? O prime number, and it says O, right? General form. O prime numbers have 2 factors. Correct, huh? Right? Yeah. This premise 1 here, it is valid and sound because it's true and it's valid from 1. Right? Of course, for premise 1, you can also give another example if it is valid and sound. We can assume this is your P, this is your P, and this is your Q, right? It can also be form 2 for this example here. It can be if x is a prime number. I change the 37 to a general x, then x has only 2 factors. Okay, these two, either one is acceptable. They are both true. Right? Okay, so ilmu itu rezeki anda semua, anda sendiri. So these are the exercise for today from your textbook. Okay, thank you class.